Now, our diagram for QT, the last thing that we are looking for, I'm going to call QT Z so I don't have to keep rewriting QT. And I have my vertical line here, my horizontal line here, so I have a right angle at TSQ. And I'm looking for my hypotenuse of a right angle triangle QT. So let's draw that in because I don't have a diagram for it already. Now I have S, Q, T, and I'm looking for my hypotenuse here. Let's see what information I've already got. My original diagram has very little information for me, but I know I have found SQ during this question. It was 10 root 2. And I found ST during the question. That was my Y. That was 10 root 3. And they're both in meters. So I've filled in the information that I've got. I don't know what angles I'm dealing with here, but I do have enough information when I fill in what I know from earlier on in the question, and we can see how these things build on each other. When we fill in what we know from earlier in the question, we're able to see that we can just use Pythagoras. So h squared, or z, I already used h, so let's just call it z squared. Z squared is going to be hypotenuse squared is equal to the sum of the other two sides squared, and that's what we do. Squared plus 10 root 2 squared. Z squared is equal to 300 plus 200. Z squared is equal to 500. I take the square root, and again, I don't need to worry about plus or minus because Z is a length, so I don't need to worry about negative lengths. Ordinarily, we'd have to worry about plus or minus when we take a square root, but we don't here because we are dealing with a, we are dealing with a length which is only ever going to be positive for this type of question. And we remember that we are dealing in meters, so that is our QT that we were asked for. And that is our job done. So, reiterating our key points. I was told that I had a vertical pole, a vertical situation, and then horizontal. That tells me I have right angles going on between my vertical and my horizontal anywhere that they meet each other. That's a key point in terms of the language that's used in these questions. I draw out separate diagrams anytime I'm asked about a length or an angle. I'm going to draw out a diagram, all of the diagrams that link into that piece of information. I wrote out 2 diagrams here for S and OR. I only ended up needing one, but I then used that one, the extra one that I had drawn, for further context that allowed me to do other parts of the question. And this is very common. These questions build on each other. So we're always going to look for where have I got right angles, and I have to be able to justify from the English or from the picture that I've got a right angle. If I don't have a right angle, it's fine. I'm just using the sine rule and the cosine rule, and I need to be careful of that fact. But I'm going to carefully figure out what I have as right angles, draw out clear diagrams, nice and big diagrams, that take up lots of the page so that I can see exactly what I'm doing. If I draw in a tiny diagram that I can't see properly, I'm setting myself up for failure. So we're going to use nice big diagrams. We don't need to use rulers and protractors and so on for them, but we do want to make them big enough and accurate enough that we can get a feel for what the question is asking us and what it means when they ask us for different lengths or angles. So the key skill is this sketching, going from here to these diagrams, because once we've got these diagrams, we know the maths involved in solving these questions. And that's what we need for three-dimensional trigonometry.